In this video tutorial, we are going to see the automatic calibration of SWAT model using genetic algorithm called AMALGAM. So this is the paper that describe about the genetic algorithm, at the same time AMALGAM. There are a lot of paper you can find about the genetic algorithm application to SWAT model calibration. Most of these are related to partial swarm optimization, differential evaluation, and some others. So here is the list of the automatic calibrations. PSO, AMS, DE stand for differential evaluation. So here we can list down the number of iteration, we can put the number of simulation that we want to perform, and the number of objective function. Here we put sum square error and the Nash substitute efficiency as objective function, and we need to update the files for simulating and the parameter we have to choose. So from the manual calibration we can have some idea about the sensitive parameters, and then we can plug them using 1. So 1 means we are activating the parameter for getting a specific range. Now we can simulate, we can put the executable running in. Yes. So now the SWAT is running inside of MATLAB interface. The good thing would be, once it is done with one spell of iteration, it will go automatically with another set of iteration until it reach to the optimal Pareto solution. They call it Pareto-optimal front, and then it will stop if it goes to the optimal solution. Now you can see that it will it just automatically start another spell of iteration, and it will continue until it gets a optimal solution, until the number of iteration that we set up, we assigned, and the results will be stored in a file called runs-amalgam.dat. So let's wait a few seconds to see some of the results. So here is the run-amalgam.dat file. If we open that, we can now see that there is a two iteration completed with sum square error, Nash substitute efficiency in the first 2 column, and the other is the range of the parameter. So in the beginning the results is not good. After 500 or few hundred iteration, then it will start giving stable results, unless the watershed is too complex or too much human influence on that. So we can keep it for a long time, or we can parallelize in the multiple core, and then you see after 3 simulation it's stored the newest one. The same way it will run until it gets a optimized value or optimal set of parameter. After getting a large number of simulation, we can see the parameter distribution. Let's say putting a threshold criteria more than 0.5, we can see how the parameters are distributed. So here is one of the results from one of the case studies. So surface water lag coefficient, snowmelt coefficient, it's like a bell-shaped curve. Some of them are skewed. So you can have idea of the parameter ranges for a better Nash uplift efficiency or sum square error. Now this is how actually the amalgam works. Once we are satisfied with the parameter, then we can put it again in the manual calibration folder. That time it will not rerun, because there's the automatic calibration is completely different. And then when it is finished, then you can see with the parameter that we obtained from automatic calibration how well they are. So you can see with those parameter ranges, this is the final output. Now the statistics are also quite good. Those parameters were taken from automatic calibration, and that's how it works. So if you have any question, please do not hesitate to send us an email. Thanks very much for watching.